Now we can build our functions using tables, which is why we have Bob the Builder over here. So we can graph a function from a table if we know its shape, and we can figure out what its shape is going to be from the data in the table, and we'll go over what that actually means. So let's refresh sketching by hand. We have this lovely little function right here. So if we were to plug in, we're going to build our table really quick. If we were to plug in -2 into this function, we get 2 times 2 to the, it'd be -2 plus 1, which is -1, plus, so that would be 2 to the -1 power, plus 1. That's going to end up with a 2. If you want to, you can pause and go ahead and fill these out on your own by plugging them into a calculator. I'm just going to be lazy. I already have them all written out. So there you go. They magically appeared. Let's graph some really quickly. So at 0, we're at 5. Let's jump over to 2, and we're going to jump all the way up to 17. And at -2, we're at 2. So we can kind of sketch that in. We know that it starts from high or from low and it goes to high. And that's going to be kind of the shape of our graph. You only really need the 3 points as long as you know what your shape is. So let's look at some tables, and we're going to see what we need to look for. So for a linear function, the tables are going to look like, well, we're never going to see the same y value twice. The first difference, and I'll explain that in just like another slide, the first difference will be the same through each one. For a quadratic, you should expect to see the same y value more than once. Realistically, you'll only see it twice. The second difference is going to be the same in this one. And again, I'll talk about this. It's a little bit confusing, but we'll make it work. And for an exponential, you're going to see a common multiplication power in your y results, or your f of x's. And so, or in your outputs. And you're never going to see the same y value twice. So it's never going to repeat itself. Okay, so I kept all of the info here. Let's look at our linear example. So we're going to look at the difference between -1 and -3. And that difference is going to be 2. You added 2 there. The difference between -1 and 2, or -1 and 1, is 2. So we're just comparing these two outputs. And then we're going to compare the next two outputs, which is 1 and 3. And those correspond to the input 0 and 1. The difference between 1 and 3 is 2. And the difference between 3 and 5 is 2. So you notice that like each time that you make a step, you're just adding 2. Add 2, add 2, add 2. When it's something like this, you need to think linear. Let's look at our quadratics. So our difference here is 1. Between 0 and 1 is 1 again. You notice as well, this number and this number, they repeated. So you expect to see the same y value more than once. Well, there we are. What's our difference between here? 1 and 4, well, that's a 3. That's a really weird number. And here we're going to see what's our difference between 4 and 9. Oh, well, that's going to be 5. That's a really weird number too. What is our difference here? So now that's our first difference. Let's look at our second difference. What's the difference between 1 and 3? Well, that's 2. What about the difference between 3 and 2? That is also going to be 2. 1 and 1, well, that one's a hard one. You can't really say what that would be. Like, you would expect it to be 2, but you're not going to see that. But between this one and the next one down, so if we plugged in a negative, like a -4 in here, you'd expect that difference to be 2. So we'd actually get -3 if we're to plug in -4. And you'll notice here, our first difference is all like wacky. It gets really big. Here, you notice at our second difference, this is what we're going to call our second difference. This is all the same. It's all 2. So when our second difference is the same, that means quadratic. When you see the same y value more than once, it also like hints towards quadratic. Exponentials. So the difference between 1 and 2, well, we can't really find the difference. Like, it works, yeah. But we could also say that 1 and 2, well, they multiply and they're 2 together. What about 2 and 4? Well, the difference, like, these two multiply. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And here, look at them. The difference here is 1, and then you'd have a difference here of 3, or sorry, of 2. And then this is where you kind of like say, wow, something's not right. Then it goes to 4. Then here it goes to 8. So you notice it's growing even bigger every time. That's because you're not actually like doing it the same way. You're just raising it to a power, which is why this is actually times 2, times 2, times 2, and times 2. So when you see something, when you can be like, oh, hey, each one of these is just like times 2, that means exponential. You'll also notice none of these are repeated. Same thing, exponential. Let's walk through some examples really quickly. Yeah. Let's do this one. So we have, what's the difference between 1 and negative 2? Well, that's going to be 3. What about between 1 and 4? That's a 3. What about between 4 and 7? That's also 3. Here's another 3. So we can expect this, since the first difference is all the same, to be linear. What does that look like? Here, let me draw a pretty axis. Oops. What? Okay. There we go. Let's draw a pretty axis. You'd expect it to look something like that. I don't know exactly where it runs in, but that's kind of the thing that you'd expect. Let's look at this next one. I'll change our color so we can know that it's different. That looks really ugly. You can tell off the bat that you're not like adding anything, because that's not going to be a nice thing to add. You would expect a decimal in the next one. So let's do 0.4 divided by 0.08. Well, that's 5. What about here? So that's times 5. Let's do 2 divided by 0.4. Oh, look, we get another times 5. And your 2 times 5, that is indeed 10, so we know that's right. 10 times 5, that's 50, so we're good there. So we did expect, as soon as you see the pattern once, you can kind of say, oh, hey, that's what we're expecting. So this one here is an exponential, however you spell it. And remember, it's going to look something, oh, that was a bad one, something like that, where it starts low and ends high. So, quick check. This is going to be a fun one. There's actually 4 questions to this, so I'm going to say pause, and then I'll go ahead a little bit, and I'll say pause. But what I want you to do is identify whether each set of data is linear, quadratic, exponential, or other. So you're going to need another sheet of paper for this probably. But remember, you're going to look at your y values, see if there's any pattern. If you see like the first difference is the same, it's linear. If the second difference is the same, it's quadratic. And if like it just is a common multiplication, then it's going to be exponential. So go ahead, pause here. And then when you're done with that, go ahead and pause here so that you can take a crack at it. And once you've done that, you're good to go. You should at least have an idea of how to look at these things from tables and figure out what the function is.